Good morning, students. Welcome to physics video session. In this session, we are going to continue our unit 6 gravitation, which we started in last class. In today's session, we are going to see some basic concepts of gravitation, like Newton's law of gravitation and Newton's inverse square law and gravitational constant, and a very important concept is gravitational potential energy. Let me discuss one by one. Students, first we are going to see about the universal law of gravitation, which you studied in your earlier classes. Newton's law of gravitation. Yes. So this law was suggested by Sir Isaac Newton, so which is used for finding what is the universal gravitational constant value, that is capital G. So he concluded two planets, so whose mass is taken as M1 and M2, which are separated by a distance r. Now see his law. The force of attraction, that is very important. Only he concluded the attraction between the two planets. So he concluded the force will be directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. So again I am telling you, the force of attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So this is the statement of the universal law of gravitation. Now coming to mathematical expression for this statement. So here the force is directly proportional to M1 and M2 and inversely proportional to R square. So removing the proportionality, we have to use one constant term. So we are using capital G as a constant. Therefore, if the force is represented in a vector form, therefore F vector is equal to minus G capital M1 M2 divided by R square into R cap. That is, the distance is denoted in vector form, so it is denoted as a unit cap, R cap. Here why we are using minus sign? Because the force will be attracted, so the distance is now reduced, so we have to consider as the negative value. Therefore F vector is equal to minus capital G M1 M2 by R square into R cap. Now see this diagram, you can understand the concept of universal law of gravitation of attraction between two masses from the diagram. So consider where M1 is the mass of one planet and M2 is the mass of the other planet, whose separating distance is denoted by R. So the force of attraction between these two planets, so the R will be reducing, so we are using the negative value. If we have to find what is the universal gravitational constant value, suppose if you know the mass of the two planets, that is M1 and M2 value, and also you know the distance between these two planets, easily we are calculate the universal gravitational constant. If you know all the values, substitute in the formula, so we get G is equal to 6.67 into 10 power minus 11 Newton meter square per kilogram square. So this is a very important value, you have to remember carefully. So 6.67 into 10 power minus 11 Newton meter square per kilogram square. So this is a very important 2-mark question. State Newton's law of gravitation. So up to you have to write. Next we are going to see Newton's inverse square law. Students, see this figure. So a point mass will be revolving around the circular orbit, keeping as the radius of r. The centripetal acceleration of the point mass is represented by A equal to minus v square by r. So we are going to find the what is the force among the value of point mass which will be rotating in a circular orbit. Now consider the centripetal acceleration towards the center is denoted by A equal to minus V square by R. This is equation number 1. Here the V is represented the velocity of the point mass and R represents the radius which will be separating the point mass from the center. Then if the velocity is expressed in quantities of R and T, therefore the V is expressed as 2 pi R divided by T. So which is B equation number 2, where T is represented as the time period of the point mass and 2 pi R represents the circumference of the orbit. Now substitute this V value in equation number 1. So we get A is equal to minus 2 pi R divided by T the whole square divided by R. And simplifying the numerator, we get A equal to minus 4 pi square R square divided by T square into R. And cancel R square and R value. So we get A equal to minus 4 pi square R divided by T square. So this is equation number 3. Now we are going to involve the Kepler's third law. So we all know the value, that is R cube divided by T square equal to constant, that is K. Now here the R cube will be split into R square and move the R square in the opposite side. So we get R divided by T square is equal to K by R square. This is equation number 4. Next I am going to substitute equation 4 in equation 3. We get A is equal to minus 4 pi square K divided by R square. And consider this is equation number 5. Since we have to find the what is the force of the point mass which will be revolving in the circular path, so I am going to find the force by using the Newton's second law. So we get F is equal to ma and substitute the A value in the second law. So we get F is equal to minus m 4 pi square into K divided by R square. And rearranging the terms in right hand side, we get F is equal to minus 4 pi square into m into K divided by R square. This is equation number 6. Here the negative sign represents the attracting force of the object towards the center. That is, where the object will be revolving in the circular path, there will be a force attracting towards the center, isn't it? So that attracting force is denoted by negative sign. And since we know 4 pi square K equal to capital G capital M and substitute in the value, so we get F is equal to minus G capital M into small m divided by R square. So which will be the final value for the calculating of force in a circular orbit. Students, next we are going to see about the gravitational constant value which will be in a earth surface and above the earth surface. Now see this picture. So this figure represents the two concepts of force experienced by the mass. One is on the surface of the earth and another one is keeping at a separate distance from the center of the earth. What about the gravitational constant value? So consider where capital G is the universal gravitational constant and capital ME represents the mass of the earth and capital RE represents the radius of the earth and small m represents the mass of the object which will be placed on the earth surface or above the earth surface. First I am going to find the force experienced by the mass in the above the surface. Therefore F is equal to minus G ME into m divided by RE square. This is equation number 1, which means from the universal law of gravitation I derived this equation. Next I am going to involve the Newton's second law for relating the force acting on the masses. So F is equal to minus ma. Here A is replaced as G, so therefore F is equal to minus mg, and this is equation number 2. Then compare the equation 1 and 2. So they are equal to force, so I can equating this equation, therefore minus mg equal to minus capital G capital Me into small m divided by Re square, and cancel the common terms in both sides, and minus minus getting cancelled and small m getting cancelled. So we get G equal to capital G capital Me divided by Re square. So this equation represents the acceleration due to gravity. That is, whatever an object will falling from the earth surface, the gravitational value will be equal to 9.8 meter per second square, which is a constant value which you studied in your earlier classes. Now I am going to rearrange this equation. Therefore small g Re square equal to capital G into Me, and this is equation number 3. Next I am going to calculate the force experienced by the object which is placed at some certain distance from the earth surface. So therefore using the same relation from the Newton's gravitational constant value, so F is equal to minus G Me into M divided by R square. Now I am going to substitute the value of capital G Me value here. Therefore I get F is equal to minus G Re square into M divided by R square, and rearranging the right hand side, so we get F is equal to minus small g into capital M into Re square divided by R square. So this equation 5 represents the force experienced by the object which will be placed at above the earth surface at a certain distance, and using this relation we can easily find the what is the force between the masses on the surface of the earth, and placed at a above distance we can easily calculate the gravitational constant value. Students, now end of the video 1. In this video we discussed some important concepts of gravitation, like universal gravitational constant value, Newton's inverse square law, and the gravitational constant where the mass is placed at the surface of the earth and mass is placed in the above the surface of the earth. Now I hope you all understand the concept which we teach clearly. So we continue in our next video. Thank you.